Thank you for watching the Water Quality Steward workshop. The workshop is part 2 of this water unit study. For part 1, please see the Environmental Education and Outreach Mobile Classroom B. You can find this video by clicking on the link in the card or in the description of this video.
Welcome to the Water Quality Steward Workshop. Today we're going to be conducting 4 activities from the Water Carnival that you can download and print from the Water Quality Steward Study Guide. Please visit www.bayoutown.com and click onto the curriculum button to find this activity and others. Now let's go over the materials we're going to need today. Well, first of all, we're going to need water, because we're going to be doing water activities. So we need about 1 quart of water for this activity. We'll also need a cup. This is a very special cup that you will find by following the directions from the Spill Thrill page. We will also need a paper towel. We'll need a ruler. We'll need a dropper. We will need a plate to hold a penny. So we need a nice little saucer of some kind and a penny. Now you can either have your penny heads up or heads down, but we do need a penny. We're going to need the Water Stretch Maze, which you can also download. And then we'll need a toothpick. We'll need maybe some blue dye. That's optional, but if you would like to do it, it's a fun activity. So we'll get some blue dye, and we need a pencil to write down all of our results. So let's get started. The first activity we're going to do is we're going to actually take a moment and understand what it means to dissolve. So we're going to take a little bit of this blue dye. I'm going to put, let's try 1 or 2 drops. Let's try 1, 2. Very good. There we go. Now we can already see that the blue dye is starting to dissolve into the water. I'm going to take my dropper here and just stir it a little bit. And earlier in Mobile Classroom B, we had discussed how so many different items that we pour on the ground actually dissolve and it carries into our watershed. So this is just a small demonstration to show you how water can actually dissolve different substances. And today what it did was it dissolved the dye. So today we're going to do a fun activity called Drops on a Penny. And of course we need a penny. So you can put your penny heads up or heads down. We're going to need our water, our dropper. But first, we're going to learn how to be a scientist. So first thing we're going to do is we're going to need our Water Carnival scoreboard and a pencil. And what I would like you to do is look underneath the exercise that says drops on a penny. And next to it, you're going to see the number of drops. This is your prediction. So you're going to hypothesize how many drops do you think, when you fill your dropper, how many drops do you think will fit on top of this penny before it spills? So that's what I'd like you to do first. So let's take a moment and write down the number of drops you think will fit on the top of this penny. Very good. Now we're going to find out how many actually fit on the head of a penny. So later on, we're going to write your results down here. Now, with a partner or by yourself, we're going to get some water into our dropper And we're going to begin to drop the water onto the penny. Now, what I'd like you to do is either count for yourself or your partner can count to figure out just how many drops. Now, you have to do it slowly. The slower you go, the more drops you will get on this penny. So let's begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have we passed your prediction? Let's keep going. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my goodness, look at that big bubble. Let's keep going. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Have I passed your prediction? Let's keep going. 31, 32. Oh, there it went. 32 drops on the head of this penny. Have you done more than me or less? Well, write down your results and share them with your partner and your teacher. Now, this is the Water Carnival scoreboard. So at the end of all of these activities, you can find out who did the best. We've actually had some people that have gone as high as the 40s and the 50s drops on the penny. So let's see how well you do.
Now that we've experimented with water sticking to itself, let's talk about how water sticks to itself and to other substances. The scientific term we use for the way water creates a strong surface or skin on top is surface tension. And what causes surface tension is the water molecules sticking or bonding to each other. And this we call cohesion. You see, water molecules are formed from 2 hydrogen atoms and 1 oxygen atom. These atoms have a slight electrical charge to them. The hydrogen atoms have a slight positive charge, and the oxygen atoms have a slight negative charge. This acts kind of like a magnet, where the water molecule, when it's with other water molecules, wants to form long chains of positive to negative, positive to negative. So when you have a lot of water molecules together, they share bonds with all the molecules around them, to their left and right, to the top and bottom. However, the water molecules at the very surface of the water don't have anything above them to share their bond with. So they share an extra bond with the water molecules next to them, making an extra strong bond, which creates that kind of a skin you see on top. The way that water sticks to other substances, not just itself, is called adhesion. And this is where water can use the same principles to stick to other substances, including pollution like chip bags or soda, and pull them with it into creeks, rivers, and eventually all the way down into the Gulf of Mexico.
When we did our activity, Drops on a Penny, we were demonstrating the surface tension that water has. Let's take a toothpick and just carefully, flat like this, parallel to the surface of the water, very carefully drop it onto the water and watch it float. Now, if you can, get down very close beside your toothpick and look at how it's almost like a skin that is wrapping up around the sides of the toothpick. That helps us to see that surface tension actually happening. And that's why we can see leaves and sticks and other items floating in the water, also pollution. This next activity is the water stretch maze. I have my maze here that has a little plastic coating on top so that my water does not absorb into my maze. I have a toothpick, I have my cup of water, my dropper, I have a ruler, I also have my Water Carnival scoreboard and my pencil. So what we're going to do in this activity is we're actually going to drop a nice size water drop onto the start position. And from there, I'm going to use the toothpick and I'm going to stretch that water through the maze. But I want to predict how many centimeters can I actually stretch that one drop of water. So you have to look carefully and see and measure with your ruler to find out how long can I actually get that measurement on that stretch of water. So you may be wondering, how can we make water stretch with a toothpick? A little trick that I've found is to take the side of your toothpick, because you want as much surface of the toothpick as possible, because this water drop is going to stick to this toothpick. It's going to pull through the maze. It's going to pull itself and stick and pull from this toothpick. So now let's grab hold of it and use as much surface as you can and begin to draw your water drop through the maze. There we go. It's moving. It's still moving. Do you see it moving? Can you see the blue water? All the way through. How many centimeters did you predict in your prediction? What was your hypothesis? Were you able to drag it all the way through? How long was it? And look, there I'm at the stop. I left a little bit behind. Okay, so now why don't you try this and find out what your measurements are. And again, share it with a partner or do it by yourself and write down your results here in the result box. For our third activity, we're going to do the paper towel absorption race. We're going to need two different types of absorbent paper. So I have a piece of paper towel here and I have a napkin. You can use two different brands of paper towel or two different brands of napkin. Either way, it's fine. You just want to make sure that you have two different types of paper because they're going to absorb at different rates. You also need your cup of water. We're going to need our Water Carnival scoreboard and our pencil. So let's go ahead and take a moment and write down which piece of paper do you think will absorb the fastest? Will it be the paper towel? Will it be the napkin? Which kind of papers do you have? So let's take a moment and write down our hypothesis and predict which paper towel do you think will win the race. Now let's continue. So what we want to do is we want to take a strip off of each piece. So we're going to cut a little piece off of the paper towel and we're going to cut a little strip off of the napkin. And what we want to do is you can either have a partner or you can do this by yourself, but we're going to hold each piece in the water. We're going to touch it to the edge of the water at the exact same time. And we're going to see which piece will absorb the fastest. So here I have a piece of paper towel and here is my napkin. So ready? Let's go. What do you see? You know, I think my napkin's absorbing faster. Can you see? I think it is. Look at it climb up that. Did you know that water could climb up paper like that? Keep your paper towels in the water until you think they have climbed as high as they can go, and then we're going to measure them. So if you want to use a ruler, this would be a good time to do that, and you can measure how high did that paper towel absorb. So let's see what we have here now. Mine just about stopped. Look, my napkin won. Isn't that amazing? Can you see the line? Let's see if I can point it out to you. Here is the line on the napkin where it absorbed, and here is the line on the paper towel where it absorbed. That's amazing, isn't it? Did you know that water could do so many tricks? For our last activity in the water carnival, we're going to do the spill thrill activity. We're going to pour water into this cup that has a very special cut in it that we measured and cut earlier from the directions from the spill thrill page. We're going to pour that water in and see how high the water will go up into the area of this slit before it spills down the side of the cup. So what we need to do is we need 1 cup of water to be able to pour it in this cup here. We need a tray or a saucer to catch the water because we're going to make a mess. And we need to make our prediction. So I am guessing that my water is going to spill in my cup at about 4.5 inches. So I'm going to use my ruler and I'm going to hypothesize that it will spill at 4.5 inches. So let's begin. I've already written my prediction down. So the slower you pour, the more likely you are to have that water come high up into the slit. Now you can do this with a partner or you can do this by yourself. But you watch and see how high the water is going to get in my cup before it spills. Now watch that slit carefully because it's going to spill. Here it goes. Has it spilled yet? There it goes. There's the spill. And what is the measurement there? 1/8 inch. I've got 4 1/8 inches. So my prediction was a little off, but we've had some people that have been able to get it very high into the slit. So now you can do this with a partner or on your own, and let's give it a try. Remember to write down your results at the very end.
As we have learned through our experiments today, water has properties that make it a powerful force for moving pollution. Now let's take a minute and look at some examples of ways that our litter can affect more than just our rivers or other local water bodies. Our first example is the dead zone in the Gulf of Mexico, right here below the mouth of the Mississippi River at the bottom of Louisiana. This is an area of low oxygen plant and animal life that is caused by a natural process that occurs in the summertime. During the summer months, as the Mississippi River deposits fertilizers, soil, and other nutrients into the Gulf, it causes the algae to grow rapidly in what is called a bloom. These aquatic plants grow so big and so fast that they block out most of the sunlight from reaching the other plants and animals in the water that need it. Then, when the algae die and break down, they decompose and use up most of the oxygen in the water. We call this a hypoxic zone. With no air to breathe, the fish and other aquatic animals either swim away or die. The challenge is, this isn't just a natural process. People can have a real big impact on it too. Neighborhoods that use too much fertilizer on their lawns and gardens, construction sites with lots of loose soil, or even farms with other excess nutrients that wash into the watershed can all make the dead zone bigger. In fact, in 2017, the map that's right up here in the top left corner, after all the floods that year, the dead zone in the Gulf was the 3rd largest in the whole world. The good news is that over time, organizations like the EPA and the MDEQ have been working with communities and individuals to help fix all this runoff and reduce the size of the dead zone from almost 9,000 square miles, like the map shows in the top left, to about 3,000 square miles that the map shows in the top right. This was the map from 2020. The new efforts, however, aren't always effective. From the map that's in the bottom is the map from later in 2020 and early in 2021, where you can see that the dead zone can still be very large each year. But with everyone's help, we can potentially improve the situation. The second example is the Great Pacific Garbage Patch. This is a huge mass of plastic and other trash that has collected in the Pacific Ocean. You can see in this picture here not only the plastic and the trash, but down in the bottom left, there's actually a diver swimming through all that trash. On the map here, you can see in the red circle is where the garbage patch is located, between the coast of California and Hawaii. When it was first measured, the garbage patch was estimated to contain over 90,000 tons of plastic. This isn't the only garbage patch though, because around the world there are smaller patches in every ocean. This is because this is where all of our litter finally ends up once it has flowed through the watershed, from the creeks into the rivers down to the Gulf of Mexico, and eventually all the way out into the ocean. The good news is people are doing something about this. The Ocean Cleanup Group is pioneering new types of technology to help clean up the garbage patches and the rivers around the world. They cleaned up 500,000 pounds of trash in 2020 and over 1 million pounds of trash in 2021. They believe that their programs could help clean up 90% of the Great Pacific Garbage Patch by 2040. But our rivers and oceans need your help too. Each person can help fix this problem by practicing our motto: don't litter, recycle. Remember, put your litter in the trash can and recycle what you can, and you can make a big difference. Now, let's review everything we've demonstrated today. First, we demonstrated the principle of dissolve and how water can break down substances into tiny particles and spread them throughout a water body. We saw this with how the blue dye spread through the whole cup as Miss Cherie stirred the dye into it, just like other fluid pollutants can spread through a water body. We also demonstrated surface tension with the drops on a penny floating a toothpick and spill thrill activities. Remember that cohesion is the property that causes water molecules to stick to each other because of their slight positive and negative charges, kind of like a magnet's poles. The water molecules on the surface, however, don't have other water molecules above them to stick to, so they share extra bonds with the molecules on either side, which creates that skin-like surface tension that we saw wrap around the toothpick as it floated on the water. We saw how strong cohesion is as the water held itself together as we dropped it on a penny, and the surface tension held the molecules together in the cup above the slit until the pressure from the amount of water caused it to spill. In our second and third activities, we demonstrated water's property of sticking to and pulling itself and other substances as it pulled itself up the two different types of paper, and as we pulled the water droplet along through the maze. Remember that adhesion is the property of water where the charge of water molecules causes them to not only stick to themselves, but to other substances, such as our toothpick or pollution. Finally, we talked about litter's global impact with the changing size of the dead zone and how even though it's a natural process, people can have a big impact on it too if they don't protect the waterways from polluted runoff. We also talked about the Great Pacific Garbage Patch and how our pollution not only affects our local community and waterways, but can impact the whole world when the watershed pulls our litter down through the creeks, into the rivers, down to the Gulf of Mexico, and all the way out to the ocean. Thank you for participating in this workshop. We hope you had fun demonstrating the properties of water. Remember, you can do a small thing to make a big difference. Don't litter, recycle. See you next time.
Teachers and parents, we have some exciting news for you. Not only do we have 4 presentations for the Environmental Education and Outreach Mobile Classroom, we have our program for kindergartners through 2nd grade. This program travels to schools and events all throughout our state and is funded by the Mississippi Department of Environmental Quality. This program is called the Rivertown Story, and it is a beautiful puppet theater that is fun and entertaining and musical and teaches students about the value of being a water quality steward. And then we have our Mobile Classroom B, which is a PowerPoint presentation and an interactive water unit. Students can participate along with Ms. Cherie and Mr. Joseph as we travel through the watershed and learn the properties of water and why water is the most powerful force for spreading pollution. Students will actually learn about their watershed and learn ways very specifically that they can learn how to do a better job of being a good water quality steward in their community. And then we have our youth workshop, which combines Mobile Classroom B with hands-on activities. So this travels to your student's classroom, and we can have about 30 students in each class. And students will have lab equipment provided by us, and we'll get to play with water and experiment and actually build a watershed and see how water actually moves through the watershed. And then we have a teacher's workshop, and teachers can earn CEUs by attending our workshop. And quite often we combine that with other partners that we have throughout the state. So we do list those things in our e-newsletter, which you can sign up for as well by coming to our website and doing all of that. And then last but not least, we have our companion curriculum. So this is the Water Quality Steward Study Guide, and it aligns with the Mississippi Department of Education Science Framework for kindergartners all the way through 8th grade. And you can adapt a lot of these lesson plans, activities, games, quizzes, reviews, vocabulary. We have lots of fun things to explore. And not only that, but we provide free resources statewide and nationally as well. So students can go on and learn all sorts of things by connecting to other websites and actually work on the computer and advance in environmental education. So we just wanted to share some of these things with you. We hope that you'll use these resources. Our companion curriculum is absolutely free. You just go to our website, bayoutown.com, look in the left-hand column, click on the curriculum button, and when you get there, you'll have a couple of options. You can go to the curriculum and download individual pages for free or the entire curriculum. Or you can click onto the storybook. And the storybook is an excellent activity for young hands and young minds. You can print it off, let the students color the pictures as we tell the story of Rivertown, and then actually fold and assemble it into their own storybook. We hope that you will use our free resources, and we thank you very much for watching our programs, for sharing them, and we hope that you'll give us a call, and one day we'll be able to visit your students face to face. Thank you so much, and see you next time.